Hello students. In this session, we'll be continuing our discussion on dyes. In the last session, we had discussed the preparation of Congo red. In this session, we'll discuss the preparation of indigo. Indigo is the oldest known vat dye. See, vat dye are the class of dyes that are classified as such because of the method by which they are applied. Generally, they are applied in a bucket or a vat. Okay, because based on this only these are called as vat dyes. So one of the most important vat dye is indigo dye. Indigo dye can be prepared from anthracinic acid. Indigo. First, I will draw the structure of indigo so that you will have an idea what is indigo, and then we can move on with a synthesis pattern. This is the structure of indigo. This is the structure of indigo. C double bond O NH. NH. C double bond O. Right. So two similar molecule. This moiety and this moiety are same. Benzene ring, NH, NH, C double bond O, C double bond O. Both are same. So we need to prepare one moiety and then we need to link them. So if you have to prepare this part, that means it has a benzene C double bond O NH. So benzene C double bond O NH is, you can go for an anthracinic acid, that is ortho amino benzoic acid. You can go for an anthracinic acid or the ortho amino benzoic acid. If you go for orthoaminobenzoic acid, so you can prepare this compound and then you can just condense it. So how to prepare it? Let us see now. So we start with orthoaminobenzoic acid, that is benzene C double bond OOH NH2. This molecule is called anthracinic acid. This molecule is called anthracinic acid. So this anthracinic acid is treated with chloroacetic acid. It is treated with chloroacetic acid. Chloroacetic acid Cl CH2 COOH. This is chloroacetic acid. When it is treated with chloroacetic acid, H and Cl, this nitrogen attacks this carbon and H and Cl goes up, that is minus HCl. It results in the formation of this compound. C double bond OOH NH CH2COOH. So this is called N-phenylglycine. This is called N-phenylglycine. So this molecule is then fused with. This molecule is fused with. This molecule is fused with KOH. Fused with KOH and NaNH2, sodamide. Okay, this is fused with KOH and NaNH2. When this is fused with KOH and NaNH2, so H2O goes off, hydrogen and oxygen. H2 from here and oxygen from goes off and it forms a bond here. Okay, so the molecule that we get is, this is the molecule that we are going to get. A benzene, right? So this will as it is. So this carbon with OH, carbon with OH. Then we have NH here. Then we have NH. This NH. Then this CH and this carbon forms a bond. So this carbon, okay, which has formed a double bond, right? And to this carbon there is C OOH group that is linked. So this is the molecule that you are going to get. This is called as indoxylic acid. Indoxylic acid. Right? Now, this indoxylic acid undergoes decarboxylation. Okay, so first it undergoes decarboxylation, then it ketonizes. That means it gets converted into its keto form. So hope you know what is a keto form and enol form. First it undergoes decarboxylation. That means loss of carbon dioxide. CO2 goes from here. So you get this compound. This compound is what you get. This is as usual. Okay, OH. Here this goes off. It is loss of carbon dioxide. Then this compound ketonizes. It gets converted into its keto form. Hope you know what is a keto form. This is a enol form. This is an enol form. It gets converted into a keto form. Enol means there is a double bond and OH. So keto form means you get a double bond here and H moves here. So it gets converted to this keto form. This molecule. This is what I get. Keto form. Anthraconic acid treated with chloroacetic acid will give you a phenyl glycine molecule. When we treated with fused with NaNH2, so loss of water takes place and you get indoxylic acid. The indoxylic acid undergoes decarboxylation to give you this molecule. This is a enol form. This gets converted into its keto form, the most stable keto form. Then this molecule on oxidation, if you carry out oxidation of this molecule, okay, when you carry out oxidation of this molecule undergoes oxidation. This molecule undergoes oxidation, okay, and we obtained the required product. Okay, this molecule undergoes oxidation and we generally obtain the required product. That is this molecule. That is condensation of two molecules takes place. Benzene, double bond O, NH, NH, and you get this indigo molecule. Okay, benzene, we have NH, this carbon, and then C double bond O. So between this carbon and the other carbon of the same another molecule, a condensation takes place. Okay, so this is the indigo tin, that is insoluble indigo is what we call it as. So this is how we go for the preparation of an indigo. Okay, so this is the method of preparing an indigo. Let us go for the preparation of another molecule. The another molecule that we are going to prepare is alizarin. Alizarin is an anthraquinone dye. You know what is an anthraquinone? It is an anthraquinone dye. Hope you all know what is anthraquinone. So alizarin is an anthraquinone dye. It can be prepared from phthalic anhydride. Hope you all know what is a phthalic anhydride. You know what is a phthalic anhydride? So it can be prepared from phthalic anhydride. So I will draw what is an anthraquinone first, so that you will have an idea what is anthraquinone. This three-membered structure. This is anthraquinone. This is anthraquinone. So it is a best example for a modern dye. You know what is a modern dye? The other day we have discussed it. So this is a dye present in the roots of a madder plant. This can be synthesized from phthalic anhydride. Okay. So first, what is the NaCl? Phthalic anhydride. Phthalic anhydride is treated with benzene in presence of aluminium chloride. Okay. Phthalic anhydride. You know the structure of phthalic anhydride? Benzene, C double bond O, C double bond O. Oh, this is phthalic anhydride. Okay. Phthalic acid undergoes dehydration to give you this phthalic anhydride. This phthalic anhydride is treated with benzene. It is treated with benzene in presence of AlCl3. In presence of AlCl3. It is anhydrous AlCl3. This does not contain water. So what happens is, this benzene is electron rich, so this is electron deficient. So this carbon attacks this, and a bond between this carbon and this ring is formed, and this bond breaks. This bond breaks. So this attacks this carbon. So what you get is here, you have a benzene ring as usual. So this double bond O as it is. So this carbon and this carbon, they form a bond. So you get another benzene ring. And this attacks. This is what you get. Right? By getting this. This carbon attacks this, and this bond breaks because the new bond is formed, the old bond should break. So you get this compound. The compound is orthobenzoyl benzoic acid. Okay, now this, when treated with concentrated H2SO4, you know that concentrated H2SO4 is a dehydrating agent. It is a dehydrating agent, that is, it removes water. So OH and H goes here from here, and a bond is formed between these two. So you are going to get an anthraquinone. Benzene ring, as usual, C double bond O. This OH and H goes off, you get C double bond O. This is what. So you are going to get anthraquinone. You are going to get anthraquinone. So the preparation of anthraquinone just involves 2 steps. Okay, but alizarin is the salt of this salt. We need to prepare. We need to go through another 2 steps. So this is the first step. Second step. Whatever the anthraquinone that you have obtained, anthraquinone is treated with oleum. Hope you know what is oleum. At 160 degrees Celsius. So sulfonation takes place. Okay, anthraquinone is heated with fuming sulfuric acid. That is H2SO4 containing SO3, fuming sulfuric acid. It can be written as H2S2O7 also. At 180 degrees Celsius to give anthraquinone 2-sulfonic acid. So sulfonation takes place. Urium is fuming sulfuric acid. Double bond or double bond O. When treated with this, sulfonation takes place. SO3H is obtained. This sulfonic acid, when treated with NaOH, this is acid and this is a salt. So acid base reaction takes place to give you a simple salt of that. You are going to get this compound. SO3Na. So you are going to get sodium salt of it. So sodium, this is anthraquinone 2-sulfonic acid. This is a salt of sulfonic acid because this is base and this is an acid. Generally, an acid base reaction takes place. Okay, so this sodium salt of anthraquinone sulfonic acid is fused again with NaOH in the presence of potassium chlorate at 200 degrees Celsius and under pressure to give you a disodium salt of alizarin. Okay, so this is again fused. This molecule SO3Na is treated with NaOH in presence of potassium chlorate at 200 degrees Celsius under pressure. Under pressure. So what happens is you get a disodium salt of this. ONA, ONA. You get a disodium salt. Okay, so this disodium salt on acidification H plus, so Na gets replaced by H, so you are going to get this molecule. OH, OH. So this is alizarin. Okay, this is sodium salt of alizarin and this is alizarin. So a very simple method it is. So we should start with phthalic acid, phthalic anhydride. Phthalic anhydride when treated with benzene. So this carbon attacks here. So a bond between this carbon and this carbon is formed. And then the bond breaks. This is what you get. Next what happens? Next on concentrated H2SO4, so loss of water takes place. That is OHH and a bond is formed. Right? A bond is formed. Then it is treated with oleum. When it is treated, sulfonation takes place and it is converted into sodium salt. Then this sodium salt, when treated with potassium chlorate, gives salt of alizarin, ONA, which on acidification will give alizarin. So this is the preparation of alizarin. Okay, now let us discuss the preparation of another important dye and a very simple dye, that is a triphenyl dye, or you can call it as a malachite green. Malachite green. This is another dye, another important dye. The preparation of this dye involves simple step. This is triphenyl methane dye. This is a triphenyl methane. Okay, so it is a derivative of triphenyl methane. So just draw the structure of this malachite green so that you will have an idea how to prepare it, so that you can get a basic idea. It is a triphenyl. When I say triphenyl, it contains three phenyl groups. It contains three phenyl groups. See? CH3 thrice, CH3 twice. Cl minus will be here in the vicinity only. So this is the structure of the malachite green. So malachite green is a triphenyl methane. See, triphenyl methane dye. So this will be double bond. Sorry, carbon length is 4. Methane dye. So see, it can be prepared by condensation of three molecules. Simple. Okay, it is prepared by condensation of, see, three. One is a benzene with a carbon. That is, you can take an aldehyde for this. And benzene with these dimethylamine groups, two molecules of that. That means 2NN dimethylamine. So this is also dimethylamine, and one molecule of benzaldehyde will work out, because we require this three phenyl group. One will be from benzaldehyde, two will be from this amine group, that is NN dimethylamine. Okay, simple condensation in presence of H2SO4 will do the work. So let us start with that. So we'll take, for this I will take benzaldehyde. I will take a benzaldehyde molecule. Benzaldehyde, that is C double bond O, H will do the serve the purpose. H. So in presence of concentrated H2SO4. Okay, so loss of water at a temperature of 100 degrees Celsius. Loss of water, H2O. Okay, you get this compound. This is what is obtained. It was condensation of three molecule takes place. A leuco base, which is colorless, is formed. So it can be prepared by condensation of two molecules of NN dimethyl and with one molecule of benzaldehyde. Okay, now later on, this molecule is subjected to condensation, sorry, oxidation, by using lead oxide. Lead oxide. Okay. Hope you're getting this. So, what happens when we treat it with a lead oxide? You see. Okay, when it is treated with lead oxide, it undergoes oxidation. okay, to form, okay, carbinol base. Okay, let us see what happens. Let's see the structure of this. When it is treated with lead oxide, this is what you are going to get. You are going to get a carbinol base. Okay, next, carbinol base when treated with excess of HCl, and this molecule is treated with excess of HCl, we obtain malachite green. We'll obtain malachite green. See what happens when you add this HCl. This lone pair of electron shifts here to form a double bond. This double bond will shift here. Okay. Then this double bond will shift here and this will go off. Okay. In presence of HCl, this will shift here to form a double bond. This double bond will shift here and this will shift here. This double bond will shift here. So what will happen is this is the product that you are going to get. This is going to remain as it is. Okay. This will go off. Okay. Now, so this only this part will remain. It is N CH3 twice. Okay. So this double bond has shift here, so there will be a double bond. Okay. Right. So double bond and with a benzene, this benzene part will be there. Double bond En plus CH3 twice. Since we have added HCl, you add Cl minus. So this is the structure of malachite green. This is the preparation of malachite green, right? Here what happens is this lone pair shift here and it forms a double bond, right? Then this double bond shifts here, it forms a double bond. This double bond shifts here and it forms a double bond, and this OH goes off. So this is what happens. So this is how the malachite green is prepared. So in this session we have prepared indigo and anthraquinone alizarin and then malachite green. Thank you.